class, now that we've done our experiment, we've collected our data, we're moving on to page 378 on the back. And here it says to explain why you would record 0 for the beginning temperature at 0 seconds. Why would you do that, Grace? Why would you do that, John?
So you have a constant.
Oh, okay, so that was our beginning. That was our origin. Here it is on our graph. At 0 seconds, we weren't at 0 degrees, were we, guys?
No.
No, at 0 seconds, what were we at? Do you remember?
66.
We were at 66 degrees. So we just have to have a starting place. Then later we were asked to describe what happens to the temperature of the water in 60 seconds. What happens to the temperature of the water in 60 seconds, Grace?
It drops 8 degrees.
It did drop 8 degrees. How did you do that so fast?
I did subtraction.
You subtracted. Excellent. It dropped 8 degrees. Our experiment dropped 8. I wonder what yours at home did if you got to do the same experiment. Now we're going to come down here and we're going to write coordinate pairs. You had a little bit of practice with this on Khan Academy last week. All we're doing is the 0 is the x-axis, that's the time in seconds, and the second number is going to be the y-axis, the temperature in degrees Fahrenheit. So our first coordinate pair is 0, and what's the first number, Grace?
66.
Are you sure?
I'm
66. And the second number, do you remember?
66.
66, 64, 61. We're going to keep going. And you can use these coordinate pairs if you want to, or you can use the ones from your own experiment. Okay, now that we have our coordinate pairs done, the directions say to construct the coordinate grid right over here and plot the points. So we come first to 0 on the x, that's at 0 seconds. If you remember, we were at 66 degrees. So we'll come up to 66, and I'm going to let Grace put a dot there. 0 and 66 for our first coordinate pair. So she went in between because we don't have all of the dashes. Perfect. Then, Grace, the second one is 10, 66. So go ahead and connect those lines, connect those dots. I noticed that's a straight line. That means no change in temperature. Go ahead, Grace, and do the 20, 64. At 20 seconds, we're at 64 degrees. It sounds like a drop, and I'm betting that the line is going to show the same thing. Great. Then, halfway through the experiment, at 30 seconds, we're at 61 degrees Fahrenheit. That looks good. The steeper the line, the more extreme the drop. Now we're moving over to 40 seconds at 59 degrees. Then 50 seconds at 59 degrees. Grace, what do you notice happened there?
It stayed the same.
So no change. I wonder why that is, John. Why do you think all of a sudden we didn't have a change? Go ahead and do the last one, Grace.
Because it's gotten as cold as it can with what it's given.
Okay, so
That makes sense.
do you think the water's not going to get much colder with those ice cubes?
Probably not.
And I think scientists could use this pattern to predict, just like John did, that since it's starting to not show as much change, that if we were to go out to do another minute, John, am I right in saying you would predict that you wouldn't see much more drop in temperature? Well, let's see where it is now. We haven't been timing it, but as a scientist, I'm curious. Whoa, 45 degrees. So it does go down quite a bit. That would be an interesting experiment to do, right? To go ahead and measure it even longer. So this is how we can draw conclusions and plot data that's not just an x and a y coordinate, but you can do a person's height, how much they grow over the years. You can do how much a plant grows in inches from days. You can even do the distance that cars can go in a certain amount of time and calculate their speed. So these graphs are endless in the possibilities. So I hope you have a good time doing these graphs at your house and cannot wait to hear the kinds of things you do. Maybe you could even share a video. Have fun.